Hi everybody, welcome to Universe-View Odyssey channel. Conflict between the principle of constancy of light velocity and the principle of relativity. Which one is wrong? Why was it embarrassing for physicists at the end of the 19th century that the velocity of light was constant regardless of the state of the observer? It was because it seemed to violate the principle of relativity, the foundation of Newtonian mechanics. If the velocity of light doesn't satisfy the relativity principle, then either electromagnetism or Newtonian mechanics is wrong. Light flies at 300,000 kilometers per second, just like to Einstein waiting for the train in front of Bern's clock tower and Superman chasing the light. The velocity of light is constant, in Einstein's stationary coordinate system or Superman's coordinate system moving at constant velocity following it. In other words, the velocity of light is constant in all inertial frames of relative motion. Inertial coordinate system is a coordinate system in which Newton's law of motion, the law of inertia, is established. Every frame that moves at constant velocity in an inertial system is also an inertial system. The Newtonian system of mechanics is described above this inertial system. Now, let's use the term inertial system to express the first question. The velocity of light is constant in all inertial systems. Why is this embarrassing? Let's go to the train station in Bern, which Einstein used to think about and commute to work. Einstein looks from the platform at the approaching train cabin at a velocity of versus sweetheart Mileva waves in the room and walks at the velocity of w, the direction the train is going. What is the velocity v of Mileva in Einstein's eyes? This problem will not be difficult. As Mileva is walking in the same direction as the train, Mileva's v equals train velocity v plus Mileva velocity w for Einstein on the platform. Therefore, v equals v plus w. If Mileva walks in the opposite direction of the train, v equals v, w. This was thought to be a frequent experience in life, and there was no doubt, Einstein was the first person in the world to realize that this was not the truth. The stationary platform and the trains that are moving at constant velocity, strictly, they are also rattling, so it's accelerated, but suppose its constant velocity, are inertial to each other trains. We calculated the velocity of objects in two relative inertial systems in this way, the theory of the addition of velocities, and we believed that it was right. So let's apply this velocity summation theorem to light. Einstein is watching a train running at a velocity of v on the platform of the Bern train station. At that time, lover Mileva lights a flashlight, velocity c, in the direction of the train at the entrance of the room. What does Mileva's flashlight look like to Einstein? Don't you think applying the velocity summation theorem, like solving the previous problem, should make the velocity v equals v plus c of the flashlight reflected in Einstein's eyes? Einstein thought so before he learned Maxwell's equation. But it's actually v equals c. Why doesn't light follow the velocity summation theorem? At that time, physicists considered the sum of velocity theorem between the two inertial systems to be a self-evident truth. This is because it is a simple theorem derived from the principle of relativity, which is the foundation of Newtonian mechanics. So physicists tended to equate the velocity summation theorem with the relativity principle. Therefore, physicists thought that not following the velocity summation theorem would go against the principle of relativity, and therefore concluded that light acted against the principle of relativity. At that time, physicists couldn't help but feel embarrassed, as if the citadel of Newtonian mechanics, which they believed in as truth, was shaken by a strong earthquake. At this point, Einstein's genius shines. He cleaned up the physicists' embarrassment with revolutionary ideas. Physicists at the time, of course, thought that either the principle of constancy of light velocity or the principle of relativity was wrong, and that anything wrong should be discarded. Which do you think is wrong? Einstein first examined the principle of constant light velocity. First, he looked at the theoretical aspects first. Einstein thought that the fact that the velocity of light in Maxwell's equation was presented as a constant without reference means that the velocity of light is constant in all inertial systems. Second, we reviewed experiments on the velocity of light. Einstein knew of Wilhelm de Sitter's observational experiment that the velocity of light emitted when a duality retreated and the velocity of light emitted when it moved forward were the same. Louis Pizzo also referred to the results of an experiment in which the velocity of light passing through a flowing liquid is contrary to the conventional velocity summing theorem. For Einstein, the Michelson-Molly experiment, an ether-finding experiment assumed as a medium of light, ether was also interpreted as evidence supporting the principle of constancy of light velocity. Through this theoretical and experimental review, Einstein firmly believed that there was no fault in the principle of constancy of light velocity. So, is the velocity of light not following the velocity sum theorem because the relativity principle is wrong? Most physicists at the time think something wrong with the principle of relativity. Einstein carefully examined the principle of relativity. The principle of relativity was first discovered by Galileo, defined as, the laws of physics are the same in all inertial systems. Thanks to this principle, we can juggle in our rooms or on the cabin of a ship sailing on a calm sea. Because the law of falling applies equally to the cabin of a house or ship. Newton accepted this principle and used it as the foundation of Newtonian mechanics. Newton used the three laws of motion as axioms in Principia. And the following principle of relativity is theorem 5, which translates the second law of motion. The relative motion between objects in a given space makes no difference whether the space stays still or whether the space moves at constant velocity. Einstein believed in the validity of the principle of relativity for two reasons. First, it is impossible that the principle of relativity, which is not perfect but well established in the field of classical mechanics with considerable truth, does not hold true in other fields, namely electromagnetism at all. Second, Einstein thought that if the principle of relativity was not corrected, the results of any mechanical experiments conducted on Earth would be unreliable. Because the Earth moves at a velocity of 30 km per second, the tone of the pipe organ will also vary depending on the direction of installation. Einstein thought that the fact that we trusted scientific experiments and that the boiling orientation of tone was not observed proves the validity of the principle of relativity. Einstein concluded that both of them were valid after examining the principle of constancy of LIHGT velocity and the principle of relativity, which were incompatible, thus one of them was considered necessarily wrong. In particular, when we recognized the validity of the principle of relativity, the principle of constant light velocity came too naturally. So what was the reason for the collision between electromagnetism and Newtonian mechanics? The velocity sum theorem derived from the principle of relativity was not true, contrary to our concept. The cause was Newton's concept of time in space. The time on the platform and the time on the train were different. Einstein began to rethink the concept of time in space. He is finally at the heart of the special theory of relativity. Thanks for watching.